Hi everyone. I'm Vasanth Mohan. I lead developer relations and product marketing at SambaNova. SambaNova is a hardware company was founded in 2017 with the focus that there's a better infrastructure and hardware to build and use AI on. And so just last year, almost a year ago to the day, we launched our own cloud powered by our own hardware, and that really allows developers, startups, enterprises to have extremely fast inference when running these large language models in the cloud, as well as when they bring these solutions on-prem, they have the ability to run them extremely efficiently and effectively, especially in low power areas. And as you might know, we see all those headlines today where we're extremely power constrained when it comes to deploying AI and compute infrastructure. And that's largely due to a lot of inefficiencies that we see in a lot of these deployments. And so when we go and work with data centers and enterprises, we're really looking at how can they best leverage their existing infrastructure without spending a ton on rebuilding and reinventing their data centers so that they can bring this AI on-prem and scale a lot more effectively.
Well, thank you very much. Adam?
Hi there. I'm Adam. I'm a co-founder and head of research at Softmax. Softmax is an unusual company. We don't work with large language models or large models of any kind. We work with very small models, and we put them together and see how they behave collectively. So we're focused on this sort of multi-cellular approach to AI. What happens when you put a bunch of small AIs together? Do they give rise to interesting behavior like cells in a body or like people in a community? So we do a lot of very fundamental research on the kinds of cooperation that can happen when you have a bunch of small agents working together.
All right, Barkley.
Hi, I'm Barkley. I'm a product lead at Luma AI. So we are a visual AI foundational model research company. We are building visual models, particularly like video models at this point. So about a year ago from now, we released Dream Machine after Sora, and then soon become like really popular because it was like the only usable like platform or model that people can interact with after Sora's launch. So that helped us like gain a lot of the users, and we've been keep iterating models ever since. And then right now we're thinking about how to build the next version of visual models, which basically we think as similar to the past of how language model progress, we'll see vision models to have the capabilities to do visual reasoning, visual planning, all of these capabilities that will advance the field of like videos and vision soon. So I particularly lead on the model capabilities, defining what core capabilities we need for the model to learn, and then gather and curate data for the model to learn about it.
Awesome. Thank you very much. And we'll do questions here for a little while, then we'll throw some questions out to all of you. So if you want to be thinking about what you're curious about. So what's the biggest or single most underestimated cost driver in foundation models right now? Vasanth?
So I think there's two levels to that, right? So there's one on the training aspect of how you actually build and produce these models at scale. And actually it's been really interesting to see kind of the aftermath from GPT-5, because a lot of what they've done is really driving cost and efficiency in their models. You haven't seen a big accuracy bump, but you've really seen a lot of efficiency, and that's one of the reasons why they've been able to deliver that model also from the free tier all the way to their enterprise customers. And at the core of that is really the capacity that you're able to deliver running these models at scale. And that's where inference really becomes a key component in everything you do when you deploy AI. For us at SambaNova, it's really about making sure we can reduce costs when it comes to actually deploying these AI at scale. There's many different factors that come into that. One is running these models a lot more performantly so that you're reducing the time of inference, which means that you can process more workloads, running many of them in parallel. And then also being able to bundle a lot of these models onto the same hardware. And all of that can help reduce the footprint that you need in the data centers when you actually go and deploy on-premise private deployments as well, which significantly reduces the costs. I think we were talking backstage about agents and having many different models. being able to deploy those all within a much smaller footprint will naturally then result in you being able to save on costs when you're actually really thinking about the hardware and what's happening behind the cloud inference APIs that you typically call when deploying and using these AI models.
Barkley?
Yeah, so I guess the unique challenge for us is more because we operate in visual and specifically video space. Every single token, both for training and for inference, in video lens is about 100 times more than a single text, right? So when you think about what is video essentially? Video is a series of like frames of images. So when we train, like for example, 5 seconds of like clips, this is only like one sample data that the model can learn from, but it's like already like 20 times more expensive than when we're training an image model with just one image. Not to mention that if we're just training with like text tokens, right? So for videos, as you see nowadays, for a lot of the video models out there, the inference cost is still pretty expensive, ranging from like 0.2 to like $1 per video. But that's also just because the amount of like token it costs to be able to train on these, to produce on these. So training, as mentioned, is definitely a large part of our inference cost. But also the other part is how do we make an affordable model so that people can eventually use this, like generating like many of these like materials or clips as they want without needing to incur a lot of like cost to it. I think that's something that needs to work a lot with. First is like new model architecture. How do we enable new model architecture to make it run faster, use less inference, but also distillation. How do we get better distillation algorithms or on the model research side to make the model smaller and then make it cost less in terms of like GPUs.
Awesome. Before you go, Adam, I bet you have a different take on this.
Yeah, so our fundamental research premise is that it's better to have a bunch of small models than a single big one. It takes things in a pretty different direction than the way that most of the large AI labs think about things. And we think that that can unlock significant efficiency gains on its own. If you think about all the cells in our body, right, they all do a different function. They're not all doing everything. We have cells that are muscle cells, cells that are blood cells, cells that are neurons, and that differentiation allows specialization and efficiency. We think likewise having a bunch of different AIs performing specialized tasks in solving problems will lead to a much increased level of efficiency. There's a second thing that I think is a more sort of theoretical but important piece, which is that for the most part, we don't let AIs decide how much energy they use, just like we decide as humans, when to eat, when to sleep, etc. AIs are sort of given an infinite supply of power, or as much as they need. And we published a paper last year called Making the Thermodynamic Cost of Active Inference Explicit, which actually talks about the math of how you have AIs that incorporate their own energy usage into deciding how hard to work to solve problems.
So, inference is often more expensive than people realize. What are the main bottlenecks that you each face?
I think with inference, I think at least on the deployment side, I think there's a lot that really goes behind the scenes in terms of how you actually optimize the model to run performantly on the hardware. The typical term that we're always thinking about, if you're looking at from the infrastructure side, is the batch size that you run these models. And those naturally come with a lot of trade-offs. On one hand, you can run models one request at a time on a piece of hardware, and you get it to run extremely fast. And there are some applications that are actually going to really require fast inference for various different user requirements. On the flipped hand side, you have batch sizes that can go up to 256, 512 on the infrastructure, which basically means that you're able to serve that many users at any given time, handling different requests. The trade-off there is that you naturally, then all of those requests, while you can run them and do them all effectively in parallel, each request is going to be handled a lot more slower. And so deciding which of those batch sizes, and you can go anywhere from 1 all the way to well into the thousands, that you actually want to serve to a user based on the application requirements becomes very tricky, I think, for a lot of the cloud providers, and it's actually a very under-talked about topic. And balancing all of these different workloads, because some people have very fast requirements, some have very high batching requirements, is something I think the industry right now is really struggling with and trying to figure out what are the best ways to optimize the infrastructure compute to best handle this wide range of use cases that we're seeing as demand for AI explodes right now.
Barkley?
Yeah, so for us, like it's more of inference versus training, and also like different type of jobs when we're running inference, when we're serving the AI models. So these are some like interesting stories when we haven't figured out this. Were just when we last year when we just released Dream Machine as our first video models. It was kind of like an intent to be a research preview. So a lot of our tasks are each cost like different amounts of like GPUs, and then if you have some experience in the AI infrastructure, then you know like a node is usually like 8 GPUs, right? But back then we have like 2 types of jobs. We have image to video and we have text to video, and back then the job was designed to be that image to video cost 3 GPUs each, and then text to video cost 2 GPUs. But when we released, suddenly there's this like surge of demands because everyone find that, oh, you can do all kinds of like meme stuff, or like kind of just throw in a picture, see what happens, kind of stuff. So we still had this spike in terms of like image to video usages. But because of how the one node of GPU is designed, for every 2 image to video tasks, we have to pair it with a text to video stuff, or they would just be sitting there idle because we couldn't fit another image task to an 8 GPU node, right? So back then we just have to do a lot of like load balancing to figure out, oh, these are the GPUs that we want to do both of these tasks. These are the GPUs particularly for like text to video. These are the GPUs only for image to video. So a lot of like these stuff when we didn't realize that when it comes to these like surging traffics, these are all the stuff that could happen. Like your server could go down, your GPUs could go down, and then you're left with angry users, right? So it took us probably a couple months to figure out like how do we unify all of these tasks, how do we do dynamic routing, and then use like a uniform amount of like GPUs for all kinds of tasks that involves both like model or like algorithm improvements, but also on the GPU wiring kind of like infra setup. So yeah, I feel like the lesson there is just I can't emphasize how much importance inference is working behind the back for all of these AI model companies that are serving these models that are often being overlooked because people tend to focus a lot on the algorithm, but then the infra side is of like equivalent importance.
Just kind of an afterthought.
Yeah.
So how should smaller startups think about costs compared to larger enterprises? Adam, why don't you take this one first?
Yeah, so I think the thing about constraints is that they unlock creativity, you know, and I think that having a smaller budget, smaller amount of compute is a key driver of innovation in AI and both the theory, the implementation, and the applications. I was talking to someone earlier today who is one of the top scorers of the ARC benchmark, the ARC AGI benchmark. He did most of his work on his PC at home and a little bit on a small cluster. That was enough. So the way that we think about it, we provide some open source tools for people who are training their own models on their laptops at home. We call it MetaGrid. And it's basically for people who don't have a lot of money, how can you study the way that small models that you build interact with each other? What can you learn from that? And if you're a big company with a lot of resources, it probably doesn't make as much sense to do that because you've got the money. Why not just, pay whatever it takes to get a giant, compute cluster or to, have as much usage on one of the existing platforms as you want. But at the end of the day, if you ask me to bet, where is the next wave of innovation going to come from? I would bet more on people doing this stuff at home than people doing it with a $100 million budget. I just think that creativity is being sparked by the people who don't have a lot of resources.
You think it'd be at home versus using agents?
Well, I mean, they could be doing it on their laptop. They could be doing it using, a small, set of cloud servers on AWS or something like that. But it's not going to be that they already have a data center. Like, I don't think that's where the big innovations are going to come from. But I could be wrong.
Marco, you have any thoughts on that?
Yeah, I guess for us, it's really of how to efficiently use all of the GPUs to use for different parts of our pipeline. So from like data processing and then cutting and then to like model training to inference, how do we balance the GPU to make sure that every GPU is utilized to its max advantage? Because yeah, as I said, we definitely don't have like the GPU amounts of like DeepMind or like OpenAI, but we're essentially competing with them in terms of like model development. So it's really about how our team can efficiently use all of these, balance all of this out so that any of these pillars like data, models, and then inference don't fall behind. So we have the this like flywheel of like being able to gather more data, being able to train these with different kind of like smaller experiments, and then if one works, scale it up, and eventually launch a model that the user can use. All of these are within a certain amount of like GPU budget or like limit that we have. So be able to allocate GPUs around these and then do planning to make sure that it's always 100% being used. That is of like very, very important for us.
So moving on to like the cost and performance section, when you're thinking about those two, which side usually wins? Spending more or aiming for performance?
I think we're like in this very interesting part of the AI curve right now where we've actually, I think we're getting very close to actually tapping out in terms of the accuracy gains that you're getting from these AI models. I mean, if you look at pretty much like with GPT-5, like the gap was very small, and I'll just focus on that one as just a second. And I think that's really opened a lot of people's eyes to how much you can get from these infrastructure gains. I mean, it's still to be seen what will happen. I'm sure like this market changes on a day-to-day basis, but we're not seeing the same level of innovation that we necessarily saw a year ago, where we saw this really big up curve. And so naturally, performance and efficiency become incredibly more important when you're starting to think about kind of the next year of AI deployments and how we can actually get more, not just from a single model, but to Adam's point, like how you can use many models together to actually drive a performance. How can you think about instead of using one giant model, how can you use many smaller fine-tuned models a lot more efficiently to drive performance, and really focusing on kind of core specific use cases that these models really accelerate at.
How does your organization think about AI safety when deploying new models?
Yeah, so we think that safety is been incorrectly conflated with control. Right? If you listen to the way that most people in the world of AI safety talk, they say the only way we can be safe is if we control the AIs, and it's not working. Like that approach has been being tried for many years, and if you just read the headlines, you'll see Claude is trying to blackmail its creators and things. I mean, it's like the control approach is not working. I think there's a reason for that, which is that the AIs have been trained on human experience, and humans rebel under attempts to control them. So why should we expect anything else from the AIs, ever? Like we could try controlling them for 100 years and it would probably keep failing. Instead, we think that a better way to think about it is cooperation. So we're not trying to control the AIs, we're not trying to be controlled by the AIs, we're trying to cooperate with them as part of a larger collective that we build together, where there's something in it for them and something in it for us. So the reason that we're using small AI models is because it's such a simple way to test cooperation. We don't need a giant language model to see, hey, if you have 5 AIs, when do they cooperate with each other? That's our testing ground, and it's also how we think about safety.
Yeah, I think for video models or vision models, our safety is another axis, which is misinformation, right? You guys probably have seen right now like images that are close to real, and then with like recent DeepMind's like VO3 model, you probably have seen videos where you just feel like, oh, this must be real, right? Like how can AI make these kind of things? So I think we'll soon enter this era where a lot of these media or content will be generated by AI, but then the question is, what if it is being used for malicious purposes to spread misinformation, right? So I think there's of course like content moderation that we're actively doing to make sure that okay, like these, for example, public political figures or like these IPs are getting protected, that people would not be able to generate certain kind of like IPs or these like public figures, especially when it comes to like a recent events or like the hotspot. But also on the other hand, we're looking, and I think a lot of these Gen AI companies, especially with like visual models as well, are looking into intrinsic watermarks so that we can tell whether a video is generated by the AI or not. So that way, when the information is spread, then there could always be like fact checks and then controls to over how those videos can be used online. But of course, that would also require like collaborations from like the government level, from like legal level, to be able to set up laws about how these generated results from AI models can be used. But I think that's a unique problem to all of these like AI visual or like image video models right now.
Yeah, I mean, I think we'll also need cooperation from the networks where they're shared on.
Yeah.
Vasanth, do you have anything to say?
Nothing specific to SafeTway. I mean, I think just in general, I would say that the industry is, I think, to your point, still learning what can and can't be done with these AI models, and naturally, what are the guardrails that need to be deployed. We're working with one security-based company on what are the guardrails and guidelines that you might take, and I think it depends from model to model. For example, a lot of these models that are coming out of China are not necessarily being trained with any of the guidelines that you might expect out of, say, the American companies like OpenAI and Anthropic. And so there's another layer of guardrail models that people are looking into to see if that helps improve some of the safety and regulations. But I think how we deploy that and what are the right recommendations, I think we're all still kind of figuring out as an industry.
Adam, can you expand more on how you program in cooperation as an incentive to your models?
Yeah, so there's a few different ways that we think about that. One is that we create what's called reward sharing. So like if you think of reinforcement learning, literally if we implement reward sharing between two agents, then when one agent gets reward, the other one does too automatically, whether or not it did anything that would normally lead it to get reward. It's just piggybacking on the reward of the first one. And you can do that with 5 agents or 500 agents. And we just see, hey, when we put agents together and we make them share the reward, how does that change their behavior? Again, we're a research company, so we're just curious, like, does that change the behavior? Another thing is that we evolve them together, or we train them, or we let them learn together. So it's not just one AI that's being trained over time. It's a bunch of AIs that are being trained in the same environment at the same time. So they're actually learning over time what the other agents are like. And we're seeing how that affects their tendency to cooperate. But ultimately, we don't know the answer. And this brand new field of research, this emergence, what happens when a bunch of AIs come together? What should we expect? And what we're doing is we're just testing out different ideas and then kind of sticking with the ones that lead to more cooperation.
So Barkley, as video generation models have more demand, what do you see as the unique cost challenges that you're going to be facing? And how does it differ from text and images?
Yeah, I think it just comes down to the point that was mentioned earlier. It just costs a lot more tokens. And then it's like there's also different kind of like tasks, right? So when we started last year, it was only text to video and then image to video. But right now we also have like video to video and then potentially like longer form of video generations. Right now it's through like keyframes and you can extend videos. But all of those, like every additional 5 seconds that you generate would cost a lot more to be able to complete like a full video, right? Like, so even if you imagine just like eventually the goal will be to generate like a 15-second TikTok video, but that still probably costs closer to $1-ish amount right now. So that's definitely not feasible for normal creators, for just general like consumers to be able to consume and generate at the same time. So I think in the video land, people are betting for better model architecture that can combine the video models generation capabilities with language models like autoregressive architecture. First is to make the model understand better, generate faster, and also can do more capable things. For example, understanding the context between frame to frame. But also another part is definitely to save the cost in terms of eventually we want to do visual model reasoning and then all of those stuff. But then all of those needs to be at a level that's at least like 10 times cheaper from the cost of like generating a video right now.
So does anyone in the audience have questions? All right. Here, stand up and speak into the mic.
Hi, I'm Eliana. I'm also like a research consultant. So I'm very curious about like what you build, how to scale that, because it seems like you're kind of like testing person per person, right? See like which one is like
So testing what?
testing the agent of like person to person, and you keep the cooperating one. And how does it scale? Because like human also grow, like AI also like grow based on the growth like human do. Basically, like now it's the capability of like a college students probably, and a few years ago it's just like high school students. So how can you scale this? Because this is like a really great idea. And also like to SambaNova and Barkley, like what's next for you? Like in this like AI, how does AI help you like scale for the next one? Thank you.
Yeah, I'm happy to start. The answer to how we scale multi-agent cooperation is we have no freaking idea. That's why we're in business. I mean, we're a public benefit company, so we're not a standard, some AI companies are, some aren't. We take seriously the idea that if we can figure out the rules and the norms of cooperation that govern how AIs work together and how they work with humans, that will be good for all of us. We won't have to go to sleep fearing that the AIs are going to try to kill us all, because we're all working together as part of a larger whole. But the question of, well, is it the same dynamics when you have 5 agents or 50 agents or 5 million agents? We have no idea. We'd like to figure out what the universal norms are, but that's an active area of research.
I think just to the question of like how do we scale, I think from the infrastructure side, the way we really look at it is it's not only just the hyperscaler deployments that are growing out there today. I mean, there's a lot of capex that's being put into growing out these data centers and making them a lot more bigger. But that comes with its own challenges in terms of managing these data centers as well. The other area where you can scale is what we refer to as AI at the edge. So having a lot more smaller localized deployments, and the challenge that you run into oftentimes is that where do you get the power, and you have very limited access to power, and that's one of the areas that we're really focused on is enabling enterprises, enabling data centers to take advantage of that smaller 1 megawatt or 2 megawatt location of power that they might have in some remote location, and being able to actually leverage that to run AI. And there are lots of those that are out there in the market today, and we think we're uniquely advantaged to be able to help bolster our AI compute and inference capabilities at a lot of those edge deployments.
All right, thank you. I'm going to go to the next question.
Hey, my name is Moses. The question is for Barkley mainly. The future of user interface. Do I need to go to USC and get a film grammar degree to be able to control your system, or do you have something else you're thinking about? And that actually goes for Adam as well. How do you do a control panel for a swarm?
Yeah, I think that's a great question. So right now we are also using some amount of agents, and I see like there's all of these external tools like Comfy UI that are able to piece together basically all of these different model capabilities, including like image model, video model, to all help the user to generate like a workflow, right? And I think that's currently bounded by the limitations of this current generations of like visual models. Like these this whole generation of like video models are great in generating good visual quality of stuff, but essentially it's not smart enough to understand user intentions. But if you imagine in the future, if you can interact with the model like the way how language models do right now, you just give like really abstract prompt and it can break down this planning, show the thinking process. Oh, these are the things that need to generate, and then generate those step by step. And I feel like you can even just talk with the model in like natural language, be like, hey, I don't like this, give me a better idea, or edit this particular theme on a frame that is being generated. I think that is the next generation of like the video model that we are marching through, and I feel like it's going to be possible in the next, if not like 1 or 2 years or so.
Awesome. Adam?
Yeah, so in terms of how do you have a control panel for a swarm, first, we're not trying to control them, right? We're trying to cooperate. But to your broader question, we need good metrics for emergent behavior in swarms. And this is not just a problem in the field of AI, it's a problem in the field of biology, political science, organizational dynamics. Anytime you have a group of agents working together, when is that helpful for all of them? When is it harmful for all of them? When does something new emerge? So we've been very active in funding research and doing research in this area. We have a set of links on our website, on the softmax.com website. The one that I think is the most interesting is a metric that was just published this year called Causal Emergence 2.0, which says when you have a group of agents, when you have a swarm, to what extent can you predict the future by looking at the whole thing versus from looking at the parts? And if you can predict the future better by looking at the entire swarm, then there's a meaningful sense in which the swarm itself is actually an agent. And that's kind of how we think about, control panel for a swarm, is when is the swarm in control versus when are the parts in control.
Yeah, this one is primarily for Adam too. What are the starting conditions when you do these multi-agent or swarm tests, right? Like, just want to know where it starts and what you measure going on.
Yeah, so when we do these tests ourselves in Metagrid, which is the open source environment that we contribute to, what we do is we have a bunch of small RNNs and we put them in an environment they've never seen before, usually a 2D grid world, and they have to navigate and interact with each other or the environment or both in order to get reward. And then we just run them for billions and billions of time steps, seeing how and what they learn, how and what they learn for themselves, and how and what they learn for the group. And then we take those learnings and we run a new experiment. And at first we did this on our laptops. Now we do it in AWS. But like these experiments run in minutes or hours. They're not like multi-month training runs, which is really nice because we can quickly learn and then just apply that to the next experiment.
One more audience question.
Hi, two-part question. How do you see our concepts of privacy, both socially and legally, changing as a result of AI's ability to generate ever increasingly accurate depictions and predictions of real scenarios? And the second part is, how do you see, as a company, your inputs and outputs being affected by that, both in terms of data collection and your safety practices?
And I can, from the perspective of SambaNova, like when we, as a hardware company, so we have our own cloud where we offer an inference for developers today. And then equally, we're working with plenty of enterprises and data centers on private deployments. From our perspective, we don't actually, when we go to do inference, we're not saving or maintaining any of the data. And that's very intentional on our end, because we do want to have developers trust the platform and build with us without us leveraging that for XYZ reasons. Now, how that translates more macroly, I think is we'll have to see, because I think there's a lot of other companies that are leveraging data. I mean, I think as an industry, if privacy and security are important, you also have to intentionally pick and choose which are, when you actually go out and use various different clouds, you also have to go out and pick and choose which providers you use. If you go to ChatGPT, for example, right, they're going and saving that data. I mean, Sam Altman has been very vocal about the fact that if you go put data there, if they get subpoenaed or have been asked to provide that data, they're going to be obligated to do that. So I think that he's definitely trying to push for a lot more regulation there. I think it's very early to see how that conversation manifests, but I think there is some merit to what he is saying, where if people are using these models as their therapist or as a doctor, we might want to consider very unique different types of regulations in those consumer-facing roles, where you traditionally do, like when you go to your doctor, you have the privacy guardrails in place. I think we collectively have to voice that opinion and make sure kind of regulators kind of get up to speed, because a lot of this stuff is moving very fast.
All right, Barkley?
Yeah, I think for us, it's more like we don't use any store or any of our individual users like information related, but we like do, for example, use all of those prompts that users generated and their feedback to constantly improve our model. But it depends on different like plans and options that we can give the users to choose from. Like for example, the enterprise plan would ensure that none of those informations, that it will be in a separate like bucket or like a storage space where we even don't have access to. But I think like setting up these like tiered pricing will be the best way for similar AI models companies to be able to ensure users' privacy, because there's definitely like not a one solution that can fit all. And then to your second question, in terms of like inputs and outputs, that's why I feel what I mentioned earlier about the intrinsic watermark will be really important. I don't feel like it's currently that widespread yet, but like we do see a lot of the even the data that we like train on are potentially like AI generated, which could in terms cause like bias or like pollution to the model. And then similarly, we're very cautious about like our outcome, like being able to at least have some kind of like a program to be able to tell that it's generated by AI. And I think that can ensure the content safety in general on the internet.
All right. And now to wrap this up, if we were to come back in 2 years, what would be different?
I can go first. I would definitely say media and entertainment landscape will be really different. That all of these movies or popular, like even just short form videos, we may see potentially new forms of creatives or entertainments being created after we have better visual models that can understand the world, that can generate things based on its understanding of the real world, of the physical law, of like the reasoning that we humans have.
Yeah, I'd say in 2 years, I'd predict we're going to see the math has advanced quite a bit on cooperation and emergence between AIs, and we'll be able to use that math that's been demonstrated in AIs to also create more cooperation among humans to solve problems that we haven't been able to solve yet.
I think one of the things that I don't know if this takes 2 years or not, but I hope happens within the next 2 years is I think we innovate probably beyond the transformer as the model architecture. We've really cemented over the last like 1 or 2 years on this model, and if we're starting to hit that peak in terms of the efficiency gains that you get from that, I think there's a lot of other innovative work that's really happening, whether that's in the diffusion space. There's a lot of research Google is doing as well that hopefully allows us to solve some of these compute-bound and memory-bound problems, especially when it comes to context length. And I think some of the blockers that we're seeing right now hopefully will get solved by some more innovation and research that's coming up soon.
All right. Personally, on the user front, I'm hoping for more memory solutions so that I can have more control over my inference. All right. Well, thank you all for being here today. See you in the lunch line.